Probability distribution. Make a probability distribution for the given set of events. For our problem, the outcome, event is the outcome, that we're looking for is the sum when you toss two dice, a pair of dice. But these dice are not going to be cubes, they're going to be a tetrahedron. They look like pyramids. Each one of these sides of the pyramid is going to have one of these sides, and there's going to be two of these. Then you're going to toss them and get the number this one came up with, the number the other one came up with, and see what the sum is. And then find what's the probability, what's the chance that that sum comes up when you toss the two dice. Remember, probability distribution records an outcome with its probability. So our answer sheet looks like this. These are the sums that we're looking for. These were picked ahead of time. And our job is to find out what probability each one of these sums has. So now let's talk about how do you count how many of those sums you could get when you toss those dice. So this is the symbolic way of saying it. Find the probability of 8, probability the sum is 12, the probability the sum is 8, the probability the sum is 16, and so forth. So take, for example, if we were looking for the probability that the sum is 8. So these are the numbers the first die could come up with. These are the numbers the second die can come up with. Sum means you're going to add two numbers. So what are the chances that when this die falls and this die falls, those two numbers add up to 8? So what you do is pair these two columns and keep those that add up to 8. So 4 plus 4 add up to 8. Notice no other pairing of these two numbers will give you an 8. There's only one way you could get an 8. So in your computation of your probability, the top number is a 1. Remember, in the probability, the top number records how many of what you're looking for occur. There's only one way you can get a sum of 8. The bottom number is the same for all the probabilities in the given problem. So all these probabilities for this probability distribution will have a 16 in the computation of the probability. Where did the 16 come from? Well, this one counts how many ways you could pair the numbers, all the different ways regardless of the sum. So you use the multiplication principle. There's 4 ways that this first die can come up. There are 4 ways this die could come up. So it's 4 times 4 gives you 16. There are 16 total ways that you could pair these numbers. And here is the explanation we just gave, the multiplication principle. Notice the first 4, number of ways available the first tetrahedron can fall. There's 4 numbers it could fall as when you toss it. And there's 4 for the second. 4 times 4 is 16. Let's practice some more, and this time with the probability for the sum equals 20. So count how many ways you could pair these two die results and come up with a 20. 4 plus 16 is 20. Okay, that's one way. 8 plus 12, that's 20. That's the second way. 12 plus 8 is a third way. And 16 plus 4 is the fourth way. So there are 4 different ways you could come up with a sum of 20. And there are a total of 16 ways you could pair them up. Remember, the denominator is not going to change. So now you reduce, and the probability of getting a sum of 20 when you toss these two dice is 1/4. So you do the same, and you'll be able to get the probability for each one of these sums. This is called the probability distribution for this particular problem.